Enterprise AI access is more than logging users in. It connects identity, roles, attributes, risk signals, data controls, and governance, so people can use the right AI capabilities safely, at the right time, and for the right purpose. By now, you've secured the major layers: identity, applications, AI workflows, infrastructure, cloud, and Kubernetes. Module 4 brings those controls together into an access architecture. Who can do what, with which data and AI capabilities under governance, monitoring, and audit. In AI systems, access is not just about opening an application. A single prompt can reach data stores, models, tools, agents, and external APIs. One permission mistake can multiply quickly. A user might retrieve restricted data, trigger a tool they could not use directly, or create actions with weak audit trails. Strong architecture connects identity, policy, data, model, and tool controls, so every indirect path is governed. A strong access model starts with the people doing the work. End users need safe, guided access to prompts and workflows. Developers and data scientists need deeper access to models, data, and testing environments. Reviewers and risk teams need visibility into evidence, outputs, and controls. Administrators and operators need powerful system-level privileges. Governance should match each group's responsibility, risk, and influence over systems. Good role design turns real work into clear access packages. For AI systems, roles should reflect job function, use case, environment, and operational duty. Keep production, development, review, audit, and administration separate. The goal is least privilege without creating hundreds of tiny roles no one can manage. Broad labels like AI admin should become role families with clear permission boundaries and accountable approval owners. After roles are defined, translate them into concrete entitlements. A manager, analyst, or AI agent should receive only the actions needed, such as reading data, submitting prompts, approving outputs, managing workflows, deploying models, or viewing audit logs. Separate human permissions from actions performed through tools and agents. Then bind each entitlement to the right environment, from sandbox to production, so access is reviewable, certifiable, and ready for incident response. RBAC is the foundation of the access model. It maps common permissions to familiar responsibilities: auditor, developer, operator, or business user. So access is easier to request, approve, review, and explain. The key is alignment. Roles should connect to enterprise identity groups and access packages, not live as isolated exceptions. Keep the model disciplined. Too many narrow roles create role explosion, so use role families, careful inheritance, and clear ownership. For dynamic risk, layer additional controls on top. ABAC treats access as a real-time policy question, not a fixed permission. The decision combines who the person is, what they are trying to use, the conditions around the session, and the exact request being made. In AI, that context matters. A trained project member may use a low-risk model from a managed device, while exporting sensitive outputs from an untrusted network may require denial or step-up approval. A practical authorization model usually starts with RBAC, then narrows the decision with ABAC. The role check asks whether the person is generally eligible: employee, manager, admin, or service account. If they pass that gate, attributes decide whether this request is safe right now, based on factors like location, device trust, project, data sensitivity, and risk. The final decision may allow, deny, or require step-up verification. Exceptions should be explicit, time-bound, approved, and logged. Context-aware access treats every request as a fresh decision. First, collect signals about the user, device, network, data, and action. Then assess the risk. Is the login unusual? Is the endpoint healthy? Is the network trusted? And is the requested operation sensitive? Policy uses that risk level to choose the right control, such as allow, block, step-up authentication, restricted export, or approval. Finally, log the outcome so audits have evidence and decisions can improve. Adaptive access should not treat every risk signal as a hard yes or no decision. When context changes, apply a control that matches the risk. Ask for step-up authentication before sensitive AI functions. Limit risky sessions with shorter duration, reauthentication, read-only access, or block downloads. For privileged actions, require stronger proof. Then keep evaluating behavior for token theft, unusual activity, or sudden privilege changes, so protection adjusts without frustrating legitimate users. Application access has to go beyond, can this person use the app? Each capability needs its own rule. A user may submit prompts but not edit system prompts. A manager may view history but need approval to export outputs. Tool use, code execution, APIs, agents, and RAG search should be controlled by role, project, clearance, and purpose. For high-impact actions, add step-up authentication, review, or approval before the action becomes real. Access governance is a life cycle, not a one-time grant. A user requests access, the right owner approves it, and provisioning gives only what the role requires. As people move between teams, projects, or employment status, permissions must change with them. Periodic reviews confirm privileged access still makes sense. Segregation of duties keeps developers, reviewers, deployers, admins, and auditors independent. Finally, access is removed quickly, with evidence retained for audit. A mature access pattern begins with centralized identity, SSO, MFA, federation, lifecycle, and groups. From there, a policy decision point evaluates each request instead of relying on scattered application logic. The decision combines roles, attributes, context, risk, and resource sensitivity. Enforcement happens wherever access can occur. Applications, APIs, orchestration layers, data, models, and admin controls. Telemetry then feeds logs, SIM, UEBA, and GRC, so access is continuously monitored, audited, and improved. User access is the first governance checkpoint. Define stable roles, refine them with attributes, and adapt decisions using real-time context. Together, those controls enforce least privilege without slowing valid work. Next, we apply the same thinking to data, AI systems, privileged access, monitoring, and the capstone design.